In this tutorial, I'll show you guys how you work out questions 8, 9, and 10, which are displayed here. Question 10 is going to be very interesting. That is an inclined plane. So we'll see exactly how we approach that. So if you want to join my live classes, so you guys can easily follow the links in the description to my WhatsApp group. And after that, I'll show you exactly how you can join my live classes. I have one every day, not every day, on Tuesday, Wednesday, and Thursday at 19 hours, that is 7 p.m. Central African time. So the classes are completely free. Everyone is welcome to join those classes. Okay, so let's get right into the class and let's see how we actually work out this question. So in question 8, they're saying the figure below shows the arrangement in which 4 discs are suspended by cords. The longer top cord loops over a frictionless pulley and pulls with a force of magnitude 98 newtons on a wall to which it is attached. The tensions in the 3 shorter cords are T1, T2, and T3 as given. What are the masses of in disc A, disc B, disc C, and disc D? Now, how do we work out this question? Well, it starts by understanding what they are really telling us. The first part, they're saying that we have this force that is being exerted on the wall this side. So this wall, it's like it's being pulled in this direction along that rope. What you have to get from here is that the tension in this rope is actually 98 newtons. What it implies is that it pulls the wall in this direction, but that's the actual tension that is actually holding disc A upwards. So that tension is holding disc A upwards and it is pulling it in that direction. But when we focus on just disc A, what does it feel? Disc A will experience the tension T1, and the tension T1 will be dragging it downwards in this direction. Apart from this, disc A also has its mass present. So the mass of disc A, will also be dragging it down. So let me say that is MA for the mass of disc A. But since this is the weight, I'll put G there. But disc A is really not moving. It's not going up, it's not going down. This system is in equilibrium. What it implies is that the mass, the sum of the forces acting on disc A has to be equals to 0. Of course, this is supposed to be equals to MA, but because disc A is not going anywhere, then this is going to be equals to 0. There are 3 forces, as you've seen, in the vertical axis acting on disc A. So what you're going to have is going up 98 newtons, going down the mass times gravity, the weight of disc A, then minus tension T1, pulling it down as well. This is what is going to be equals to 0. So let's copy this. We know what T1 is. T1 in this case is given as, that is 58.8 newtons. That is what our T1 is. So we get this and let's work it out. What are we going to find as our T1? So from here, of course, we're just solving that equation. We know not our T1, we're looking for MA, So I'll move the MAG to the right side. So I'll have minus T1 equals to MAG. Substitute what T1 is. We now have 98 minus 58.8 equals to MA. We know what our G is. That's 9.8. Divide both sides by 9.8. Start with MA. We now have MA is equals to 98 minus 58.8 divided by 9.8. From here, of course, MA comes out as 4 kgs. But when you look at everything else in this question, everything else, this is given to 2 sig, this is 3 sig, this is 3 sig, this is 2 sig. So when I look at the question, the least significant value here is to 2 significant figures. So because of that, I'll also present my answer to 2 significant figures, meaning this becomes 4.0 kgs. So of course you can give it also to 3 sig, really it's going to be okay, but if you're going to follow the rules of significancy, then your answer has to be in the same way, or has to have the same significancy as the least significance value in that question. That is MA. Let's go to MB. So again, I want to isolate MB here, and I'm asking myself the same questions. What are the forces acting on MB? So I'll draw MB here. I want to draw a free body diagram of the forces acting on MB. Again, MB will experience the tension going downwards, and this tension is this T2 here. So T2 is going down. Then apart from that, T1 is holding this mass from falling down. So T1 has to be dragging this mass upwards. That is T1. Then the only thing that is left here is the mass here. This mass also has its own weight. So the weight of this mass will be dragging it downwards as well, since we know the weight always goes down. The mass is mb, so it's mbg. So when you look at the sum of the forces present here, again, this mass is not going up, it's not going down. So sum of forces has to be equals to 0 because the acceleration is 0. So here there are three forces again. T1 goes up, so we're going to have T1 minus T2 goes down, and then mbg goes down. This has to be equals to 0. We know what T1 is, just like before. T1 is 58.8 and T2 is 49 newtons, 49.0. So I can copy this so that we can work it out now up to the final end. So leave out the diagram, I'll just get this. Let's see what we're going to get here. So like before, we make the substitution. We know what T1 and T2, we know what they are. So we have 58 here, 0.8 minus T2, that is 49. I'll take the mbg to the other side, so I have mb by 9.8. I'll make mb subject to the formula, then I'll start with it. So this will be 58.8 minus 49, then divided by 9.8. And this is what will give us the answer for mb. And for mb, we're going to find 1 kg. So of course, to do sig as well, this is going to be 1.0 kgs. In the same way, we go to C. Again, for C, we want to isolate the mass C. And what we notice that for C, we're going to have T2 be pulling C up, so we're going to have T2 there. And then T3 will be pulling C down, so we're going to have T3 there. Then this is going to be MC times G. So in the same way again, we're going to have T2 pulling it up, minus T3 pulling it down, minus MCG pulling it down as well, is equals to 0. So this is what we're going to be simplifying. And we know what TC is, we know what T2 and we know what T2 is. T3 has always given 9.8. So T3 is 9.8. Like before, T2 is, that's 49. These are in newtons. So let's simplify this so that we can get our mass. But already from here, you see it's the same way as the way we found MA and MB. So all we have to do is, our T2 is 49, T3 9.8, the MCG goes the other side, so I have MC times 9.8, then make MC the subject. We have 49 minus 9.8 divided by 9.8. If we do this, we find MC again as 4.0 kgs. In the same way, we go to the last mass. But for the last mass, we don't have tension there. So in this case, for D, the disk D, we only have its weight going down, and the weight is MD with G here, and the tension T3 dragging it up. So this is a free body diagram for the last one. So we're going to have T pulling it up minus MD pulling it down, G, then this is going to be equals to 0. So this is all that we're going to be working out. We still have T3 from the previous calculation, so just use it from there. So this is what we have. We take MD to the other side, so we have this is equals to MD with G here, make D subject, MD I mean, so we have MD is equals to T3 over G. Make the substitution. T3 is 9.8, so we get 9.8 divided by G, which is 9.8, so you get MD as 1.0 kgs. So this is how you work out this question. Now we move on to the next question, which is question 9. How do you pull it out? So in this case, what are they saying? A block of weight 3 newtons is at rest on a horizontal surface. A 1 Newton upward force is applied to the block by means of an attached vertical string. What are the what are the A, magnitude, B, direction of the force of the block on the horizontal surface. So the first thing is to try as much as possible to understand what the question is saying. So let's say we have a block on the surface. Of course, we know to say the block will exert the weight down. The weight of the block will be applied down, so that is going to be mg. What we're given here is not mg, it's not the mass. Instead, we're given what the weight is. So this actually gives us the weight of the block like this. Without nothing else exerted here, by Newton's third law, we know to say there's going to be a reaction. So the reaction now comes from the surface and it's exerted on the block and it goes up. Provided the block is stationary on the surface, it means that the applied force, the 3 newtons, which is the force the object exerts on the ground, is going to be matched by the reaction from the ground according to Newton's third law. So we see a 3 Newton upward force as well. This of course is the one that we always take as the normal force. But in this case, so we know to say, or in this case, the question is telling us to say we actually apply an upward force. A vertical force is being exerted on our block, and this vertical force is of magnitude 1 Newton. Now the question is, what will be the force, the net force that this block will exert on the ground? The only force that we have left out here is the reaction from the ground. Now, what does the ground react to? It obeys Newton's third law. It reacts to whatever the block is exerting on the ground. So the reaction force here is actually what we're looking for. The reaction force will depend on what the block exerts on it. So the reaction force will be a comparison of these two forces being exerted on the block. Because when you combine these in a vector way, of course, or what will remain is what will determine whether the block goes up or the block goes down. So of course, if the net of these two will be a downward force, then it will be equivalent to the reaction force Fn. So again, the reaction force Fn is actually a force that is equivalent, but just opposite in direction, equivalent to the force the block exerts on the ground. So if you look at my free body diagram here, we can actually get what the question is asking us to find. So let's look at this question. That's question 9. So we start with our free body diagram. This is what we have. We have established that we are actually just looking for what Fn is. If we can get Fn, then we have found the force that the block exerts on the ground. So upward forces, we have Fn itself, the normal force, also plus upward force, the 1 Newton force, the applied force. But going down, we have the weight of the block, which is 3 newtons. But because the block here is not going up or down, even though we have that interaction, it means that this actually has to be equals to 0. So this quickly becomes Fn. Then when we combine these two, we have minus 2. This is equals to 0. So that in the end, we have Fn is equals to 2 newtons. This becomes, it is the normal force, but we conclude that when we find it here, this is a normal force. And you know the normal force is a reaction from the ground onto the object. It's an upward force. But the question is asking for the force that the block exerts on the ground. So in other words, the question is asking for the force that this normal was actually reacting to. So what the question is asking us to find, it has to be 2 newtons. So this is the force that the block exerts on the ground, but the direction is actually a downward force. So it's 2 newtons downwards. So this becomes the force that the block exerts onto this this surface. So they wanted the magnitude and the direction, so we have specified the magnitude is 2 newtons and the direction is downwards. So with that, we can move on to question 10. Now question 10 is all about inclined planes, and before we even look at that question, let's just see a few things that you need. If you have an inclined plane like this with the angle of inclination here, theta, and you have an object like this, I think we already did an intro to this, so I hope you guys had time to see it. Of course, we know to say the block here is going to have its weight going vertically downwards. That will be the weight. So in this case, if we were to now change the axis to make it easy for us to actually describe the motion here, the angle here is going to be the same as the angle this side. Now, the x component of the weight, so the weight is here, this is mg, it will have x components. Of course, x component being that we have redefined our x-axis to be along that, along a line parallel to the plane, and the y-axis being along this line, which is perpendicular to the plane, to the inclined plane. So the x component here, what we observe is that the x component is going to be something parallel to the inclined plane. So the x component will be here, and the y component will be something like this one. So y component will be this side, our x component will be here. Now, of course, we saw in the intro to forces that the force here, the x component is opposite to that theta, so it will be given by sine. It will be mg sine theta, and the y component is going to be mg cos theta. So when drawing my free body diagram for an object on an inclined plane, I don't even have to go all the way to show the weight there. I can just do this. I know to say the x component will always be going down the inclined plane, and it will always be equals to mg sine theta, while the y component will always be going something like this, and it will be given by mg cos theta. Of course, this is where theta is this one. So if we try to use the same logic on our question now, what is our question saying? We have this block. So in the figure below, a crate of mass m is equals to 100 grams, 100 kgs is pushed with at a constant speed. What does constant speed imply? Well, if we had the sum of forces here according to Newton's second law, it's supposed to be equals to ma. But if the speed is constant, then the acceleration has to be 0. So implying that regardless of where we're looking at it from, acceleration is equals to 0. So this has to be equals to 0. Just keep that in mind. So what else? Frictionless ramp. So friction is not being exerted here. Theta is equals to 30 degrees. So where is theta? Theta is here, 30 degrees. So we know what that means. So first we start with the free body diagram. I'll trace around this block. And then next I'll show my forces. So I'll start with the weight. The weight goes downwards. Its x component will be dragging it backwards. And as we saw, this is mg sine theta. And the y component will be going something like this. And this will be given by mg cos theta. Of course, the theta is 30 degrees. Then next up, we see that we have that applied force F. Of course, we know to say there's going to be a normal force as well. So let me just put the normal force as well. So the normal force will be acting always from the surface, going vertically upwards. So I'll label this as Fn. And when I look at the applied force is at an angle when I compare it with my new x and my new y. My new x being this one. Okay, and my new y being this one. So this applied force is actually at an angle. So I want to resolve it as well so that it comes, it has components in my new axis. So I see that if this angle here is theta, so you have to see if this angle here is theta, so literally this, what it implies is that even here I can say this is theta here. So if this is theta, this here also has to be theta. So you have to see that these two angles are literally the same. So if this is theta, this also has to be theta. So this means that we can literally use theta there as well to resolve our force F. So the x component of F is going to be this side, and it's going to be side by side with the theta there, so it will be given by cos. So this component is going to be F cos theta. The y component will be this side, and it will be opposite to my theta, so it will be given by sine. I can draw it here since it will be acting at that point, or I can even put it here. It doesn't matter. All I want to show is that the y component is going to be going down. So this is going to be F, and it's going to be given by sine theta. With this done, I'll just copy this so that now we can evaluate what we need. Let me just get the mass. Mass is 100 kgs. What we want to find is, in the first part, what are the magnitudes of F, meaning here they want the magnitude of F. In the second part, the force on the crate from the ramp. So the force on the crate from the ramp. Guess what that force is? The reaction from the ramp onto the crate. That's just the definition of the normal. A force that is exerted onto an object by a surface. The only missing thing there is it's perpendicular to the surface. Okay, so this is what we collected from the question. If we sum forces in the x-axis, so let's sum forces in the x. The question is saying it's going up at a constant velocity, so this has to be equals to 0. I count two forces in the x, that is this one and this one, in our new x there. So to the right, I'll take up the inclined plane as positive, so we're going to have f cos theta. Then I'll take down the inclined plane to be negative. There's no friction here, so we'll only have those two. So this is going to be mg sine theta. This has to be equals to 0. Then we have f cos theta is equals to mg sine theta. Then f will be equals to mg sine theta over cos theta. So at this point now is just simplification. We know what the mass is, that's 100. We know what g is, 9.8. We know what theta is, that's a 30. Then this is over cos 30. If you want to play around, you can say sine theta over cos theta is tan theta. But of course, you can just simplify this using any means at your disposal. And if you did that, you should be able to find your F as 566 newtons. So they only wanted the magnitude, so that is the magnitude of F. The only missing part here is the second part of the question, which is the force from the inclined plane onto the object. And you have to see that that's the normal. So in the y-axis, I count 3 forces. So I'll say sum of forces in the y. Again, this object is not sinking into the inclined plane, so this has to be equals to 0. There's no acceleration in that axis. So say going up, which is Fn, is positive, then the other two forces are downward, so I'll say F sine theta negative, then minus mg cos theta, also negative, is equals to 0. So from here, I'll just copy this. And then let's go play with it the other side. Okay, so from here, we see that we only want Fn. I'll take everything the other side. It all becomes positive. Then this is mg cos theta. We already know what F is. That's 566. This is sine theta. And this is plus. The mass is 100. G is 9.8. Theta is 30. So I might as well put 30 here. So of course, now it's just a matter of simplifying this. But with the math, you should be able to get your force normal as 1.13 by 10 to the power 3 newtons. So this is how it is done. Now guys, I hope you found this video helpful. Again, if you'd want to join my classes, follow the links in the description to the WhatsApp group. After that, I'll show you guys how you can join my classes for free without having to pay anything. Now guys, we'll see you guys in the next tutorial. All the best.